So this video is for research methodology and for small methods mainly in process algebraic framework. So researchers, this video is for researchers who want to do research in formal methods mainly in process algebraic framework. I will provide the research methodology concepts in process algebraic framework. In process algebraic framework, first we know what is formal methods. Then you must know about what is process algebra, and then research methodology. So what are the formal methods? So formal methods are mathematically based technique and tools that can be adapted for checking the correctness and analyzing the performance of modern distributed system. And what is the process algebra? Process algebra is an algebraic language for describing system behavior. So formal methods are based on mathematical concepts because mathematics is the oldest science by which we can prove the things, the real world things, using modeling in mathematics. Process algebra is one of the formal methods. It is an algebraic language for describing system behavior. Now the next concept is, so what is the formal methods? Mathematically based techniques and tools. What is the need of formal methods? To prove the correctness of any system which can be mathematically modeled. And what are the problem of existing systems? Empirical testing of correctness. In the empirical testing used in proving the correctness of systems have some drawbacks. In this testing, we are using case by case testing. Suppose we have to prove the correctness of this system. We have taken 1 to 10,000 cases and test on these cases only. We have taken the data and we have we have organized the 10,000 cases. We prove the testing. We prove the correctness on the basis of these case testing. The problem arises if 10,001 case, 10,001th case arises at the time of actual implementation of the system, then our testing fails. So our formal methods prove the correctness on the basis of mathematically model proven system. We model the real world problem mathematically, then we show theoretically proof for the correctness, and that is called formal verification. So this is called formal verification. And the need for formal methods arises because of the failures occurs in our everyday life interactive systems, and the failures of these systems may be very expensive in terms of money, face value, time, etc. In last few decades, process algebra offers a powerful and rigorous approach for establishing the correctness of a computer system. Now, this is the formal methods. And what is the process algebra? As I told you, that process algebra is an algebraic language for describing system behavior. Now we discuss the research methodology in process algebraic framework. process algebra, we describe the system behavior by using two semantic views. First semantic view is reduction semantics. It is related to the internal interactions of the system. While another view is, second view, other view is action semantics. It is related to external interactions between the system and its surrounding environment and its surrounding environment. One point is here, reduction semantics tells how processes may evolve. How processes may evolve. The action semantics describes how processes can interact with other processes which may be the part of a larger system, which may be the part of a large system. Action semantics interprets the language as LTS, Label Transition System. Label Transition System. So now we discuss the reduction semantics. In reduction semantics, in reduction semantics, we see the internal actions, internal reductions, which are not visible by the external person. Reduction semantics are written format of A reduces to B. Here there is no label. This is the represent the internal actions. If we take example of reduction semantics, when we go to the ATM machine, we are the external observer. We can see only the card is inserted in the machine. But what happens inside by reading the details of our card, then counting of the notes which will be comes out from the machine. So the internal actions cannot be viewed by the external person. So these type of actions are called internal actions. So how processes may evolve. How processes may evolve. And what are the action semantics? In action semantics, we have A to B, but some external actions happens here. Some external actions alpha happens here. For example, on a button, power switch button, we press the button and we go to the next state. Suppose first state is on, second state is off. So we press the button and we get the next state. But this action is visible by the external person. So reduction semantics show the how the process evolve internally. A system can be defined how we can define the system. and how we can define the system behavior. This is the question here. So system can be defined by the set of some internal processes, and how they processes, how these processes interact with each other is called behavior. So reduction semantics, so the reduction semantics involve the internal processes, how the process interacts internally. And the what is the action semantics? It shows that how our processes interacts with other processes in a larger environment. How they interact with the environment, how they interact with the external environment. So when the external environment comes, then the internal or some external actions will be there. Now, by defining the reduction semantics, we take some examples to show that the working of reduction semantics. But if the system A using the reduction semantics reduces to system B, how can we say that A is reduces to B, then V is consistent? How we say that reduction of from A to B is also will show the consistent behavior? In this respect, we develop some well formed conditions which tells that if system A is reduced to B, then A and B both are consistent. Well-formed conditions, conditions for the configuration. Because I am taking the concept research methodology, so I am not going into the detail, but in the next lectures we will go in the detail for each and everything, and we will take the specifically process algebra pi calculus. So well-formed conditions must be there, and you have to prove some theorems. If well formed, then reduction to B, then B is also well formed on the basis of conditions. The basis of conditions. And as we say, examples show the working of productions. Working examples show the working of productions. Next thing comes, how can you say that your system modeled by you modeled is feasible? For this purpose, you have to take some pre-existing model which will be similar to your model. Proposed model. Then say we have taken some model that is called specification for your, and your model is the implementation of this. So you have to set the equivalence between specification and implement. So specification is the pre-existing, and this is your now proposed. So you have defined the equivalence between the specification and implementation. So one thing is there, the in the previous existing system you have some systems, then you have process, here you also have the system. First you have to map between the corresponding system terms and process terms. You have defined some function which really corresponds between the system specification system terms and process term to the implementation proposed work system and process terms, and you show the equivalence between specification and implementation. Then you can say by proving, because then you prove theorems show the equivalence. So this is the one part. You can show the specification and implementation equivalence, and this is the one part. You have what you have done in this part. You have defined the reduction semantics. Then some examples: well formed conditions, you on the basis of these examples and reduction symmetry, you have to equate between specification and implementation. You set the equation between specification and implementation. Then you show that your proposed model will be feasible. If you show that, then next part comes. And what will be the next part? That is the action semantics. In action semantics, you show that A, do some external actions alpha and reduce and convert and reduce to B. Again, you have to show the behavioral equivalence between two views. One thing missing is structural equivalence. Two systems, two processes will be equivalent if they are computationally same. Then they are called. So we have to done in detail. We will do discussion on in detail for the structural equivalence next video. So you will define the LTS here. Label transition system will be defined here. These are also called action semantics. Then take some examples. to illustrate the LTS. After that, we will show the equivalence between internal view induced from the reduction semantics and external view induced by the action semantics, and we will show the equivalence between, set the equivalence between these two views, which is called full abstraction. Again, because how we do the full abstraction, there are two things. Action semantics have the very equivalence technique, it is called Y simulation. Using this Y simulation, we prove the full abstraction. So, in concluding remark, what we have to do? Define the system, syntax, then define the reduction semantics, third, so the equivalence between, also define the structural equivalence, structural equivalence. So the equivalence between specification and implementation. After that, define the LTS for proposed system. By simulation, pre-order simulation, then define observational properties, by which, by using the observational properties, because if we can observe the external actions and we can also implement the observation in the internal actions, then we can say that both external view and internal view are same. And external. So friends, today I gave only the introduction about the methodology for the process algebraic framework. In next video, I will give you the example based on this methodology. If you have any query, you can ask me any query on my email ID FVDR Baghel 2020 at the gmail.com. So this lecture gives you only the introduction for the methodology. In the next video, I will discuss in detail each and everything, and also the example, working example for my this research methodology. Thanks a lot. Good night and Merry Christmas.